Hi, I'm Joseph Corey. I'm a professional engineer, IT consultant, and entrepreneur. As a professional engineer, I've logged over 8,000 hours managing projects. Driven by an entrepreneurial motivation, I have founded and sold 2 IT-based businesses and have been involved in the e-learning market for the better part of 12 years. I write for an IT-based e-learning blog and am a published author for the IEEE and will often speak at IT conferences on technology-based subjects globally. The CSSLP, Certified Secure Software Lifecycle Professional certification, indicates to the world that security professionals are well versed in the ways to incorporate key security practices into all lifecycle stages of software development. In this course, I'll explore secure software concepts such as covert, overt, and encryption. I'll also differentiate between different integrity concepts such as hashing, digital signatures, code signing, reliability, alterations, and authenticity. I'll move on to describe different availability concepts such as failover, replication, clustering. I'll discuss scalability and resiliency. Then I'll describe authentication concepts such as multifactor authentication, identity and access management, single sign-on, and federated identity management. And I'll differentiate between different authorization concepts such as access controls and entitlements. Lastly, I'll list accountability concepts such as auditing and logging and describe non-repudiation concepts such as PKI and digital signatures. In this video, we'll consider the core concept of security, that is confidentiality. Confidentiality refers to preventing the disclosure of sensitive information to some unauthorized party. This is a core concept of security and involves keeping that information secret. Methods for keeping data confidential or secret include employing access controls to control who has access to what, and encryption. Now, we're talking sensitive information, but it's not just users' sensitive information. No, this is also related to organizations. For example, organizations have trade secrets, intellectual property, and business operations information. Now, these are sensitive information owned by the organization, and their unauthorized disclosure may create serious problems for the organization or damage it in some way. Unauthorized disclosure can occur through different channels. One such channel is an overt channel. Disclosure could be intentional or accidental through an overt channel, but it involves someone seeing the information that they're not authorized to see. For example, fields clearly displayed on a screen with confidential data that an unauthorized individual is able to see, or perhaps credit card data that's clearly visible on a report. These are overt channels. A covert channel is a channel that uses shared resources as a path for communication. This essentially involves data being made available through hidden channels in a breach of policy. The two main types are timing and storage channels. With a timing channel, unauthorized disclosure can occur by affecting or altering the performance of a system component or manipulating resources, particularly affecting the timing in a predictable way. With a storage channel, data can be written to storage and later disclosed. One good example of this is using some form of steganography tool to conceal data, for example, within pictures. In this way, digitized text can be secretly embedded within a digital image. Encryption involves a way to scramble data and can only be unscrambled using a decryption key. This is common for both data in transit as well as data at rest. In this video, we'll explore the core security concept known as integrity. When we talk about integrity, we're talking about protecting data. It could be sensitive data or even data related to system processing. And we're protecting it from any form of unauthorized alteration or modification. We can verify the integrity of data using hashing. Hashing functions just take a variable length input and output a hash value. Three common hashing techniques are MD5, SHA-1, as well as SHA-256. Consider, for example, a Word document. If hashed, it will have an irreversible hash value. If anything at all changes in the document, let's say a space was added, well, that document would have an entirely different hash value. That way, it's clear that the document has been altered. A digital signature accomplishes two things. It verifies integrity and authentication. For example, consider a secure message. A digital signature verifies the sender, but